Hey class, in today's lesson we're going to talk about law of sines, which is found in section 6.1 part 1. Our objective is to use the law of sines to solve oblique triangles, those that are in the form of angle, angle, side, and angle, side, angle. So oblique triangles are triangles with no right angles. Remember, oblique actually means that all the angles or all the angles have different measurements. In standard notation, the angles of a triangle are labeled capital A, capital B, and capital C. Again, those are the angles. And they're opposite sides, and we know opposite from SOHCAHTOA, right? The opposite sides are labeled lowercase a, lowercase b, and lowercase c. We'll see this put into place in just a moment. All right, so to solve an oblique triangle, you need to know the measure of at least one side and any two other parts of the triangle. So for law of sines, you need, you can either have two angles in any side, which would be angle, angle, side, or angle, side, angle. Or you would have to have two sides and an angle opposite one of them, which would be side, side, angle. The other ones that we'll get to later on will be law of cosines. And law of cosines will state that you can use that formula as long as you just have the three sides, or if you have two sides and their included angle. And what it means by included angle is it's the angle between the two sides. So in law of sines, this is our formula. It says if triangle ABC has sides A, B, and C, then side A over sine of angle A equals side B over the sine of angle B, which is also equal to side C over sine of angle C. And of course, you wouldn't use all three at the same time. For example, if you only had the first two, so like A over sine A equal to B over sine B, then you kind of set it up as a proportion. Or you might have B over sine B equal to C over sine C. That's a problem. Or you might have A over sine A equal to C over sine C. So again, it's not all three at the same time. You just do two at a time. And the same is true for its reciprocal. And we know we can do that again because essentially these are proportions. So I clearly spelled that wrong. It says example number 1, given, not given, given two angles and one side. So this would be called angle, angle, side. So it says for the triangle, capital C is 102.3 degrees and capital B is 28.7 degrees and lowercase b is 27.4 feet. Find the remaining angle and sides. Okay, so let's take a look. And be sure that everything is labeled and it makes sense the way it's been labeled. So right now in the upper corner, we have a capital C, okay? And that capital C matches with lowercase c. Remember, the angle, whatever the name of the angle, its side is a lowercase version of it opposite, okay? Just like this capital B is lowercase b over here, and this capital A is lowercase a over here. Okay. And this is considered angle, angle, side because we were given B, we were given C, and then we were given lowercase b. So this is angle, angle, side. Therefore, we're going to use law of sines. So the first thing that we want to do, if you've been given two angles, you might as well find the third angle, right? And we know the sum of a full triangle. So sum of a triangle I'm supposed to say angles of a triangle equals 180 degrees, right? So if I wanted to find A, I would do 180 degrees minus 102.3 degrees minus 28.7 degrees. And that would actually give us 49 degrees. Okay, so A is 49 degrees. I'm going to add that to our triangle and put that in color. Okay. Now after that, we just follow the proportion. So you always want to start with the information that you've been given. So the true facts that you were given as far as angles, you were given angle C, angle B, and little b for the side B. So one of your true proportions has definitely got to be B's proportion, because B is the only full proportion that you were given, right? So to find any of the other sides, I'm going to set it against that one. So what I mean is it's always going to be B over sine B equal to whatever I'm looking for. So I also want to find side A. So that's going to be A over sine A. And then the other one I'm going to do is B. I don't know why this keeps erasing. This is weird. So B over sine B. Interesting. B over sine B equals little c over sine C. All right. So if I set that up, that would be 27.4 as my side over sine of 28.7 equal to little a is a I don't know, right? Little a over sine of 49, which we found using our math. Okay. To find a, we're just going to cross multiply. So you're going to multiply 27.4 times sine of 49. Be sure that you are in degrees as your mode on your calculator. And then you're going to divide it by sine of 28.7. That will give you little a as about 43.06 feet. Okay. And the next one, again, substituting in that information, we would have 27.4. And that's feet, by the way, over sine of 87. I don't know why I said that. 28.7, sorry, is equal to little c now over sine of c, and that's sine of 102.3 degrees. Okay. Again, cross multiply. You'll multiply 27.4. Okay, that's weird. 27.4 times sine of 102.3 and divided by 28.7, right? And you'll get C as being about 55.75 feet. Okay, I can't box it, but that's how it works. All right, let's look at the next one, or the last one. Okay, in example 2, again, I don't know why my stuff says given. It is clearly given, but whatever. Given 2 angles in one side for angle side angles. So it says a pole tilts toward the sun at an 8-degree angle from the vertical. And it casts a 22-foot shadow. The angle of elevation from the tip of the pole of the shadow to the top of the pole is 43 degrees. How tall is the pole? So what I'm going to do is I'm going to kind of draw this out. It's better to draw it. So we have a pole, and we know a pole typically is a vertical pole, right? However, it says at an 8-degree, it tilts toward the sun. So let's draw. Okay, so here's the sun, little sun. Okay, and we have a pole that tilts toward it. Okay. Let's say it's a light pole. Sorry. Okay, so there's a light pole. It tilts toward the sun. If this is the ground. Oh my goodness, this pen is not working. Okay, it tilts toward the sun at an 8-degree angle. So if this was the original, we're going to call this part right here 8 degrees. Okay, So it tilts toward the sun at an 8-degree angle. The shadow, so obviously the shadow is on the ground. The shadow is 22 feet. It says the angle of elevation from the tip of the shadow to the top of the pole is 43 degrees. So, okay, so let me go ahead and draw this. My goodness. Okay, so if we were talking about an angle of elevation, that means that this portion right here is 43 degrees. If it was 8 degrees toward, and we know a right angle is 90, then that means that this angle here is actually 98 degrees. So really it's only this angle here that we don't know, but we'll figure it out. Okay, so let's go ahead and start putting some labels on here and make it a little bit easier for us to see. So let's say that I want to call this angle A. Okay, goodness. A. This will be B, and this will be C. C is the one that we don't know as of yet. Okay, if this is little a, that means that this side then opposite from it is little a. If this is angle B, then this will be side B, and if this is C, then the 22 feet is side C. Okay. All right, first thing that you want to find is the angle that is missing, which is C. So to find C, it would be 180 degrees minus the two angles that we found. So that's 98 degrees minus 43 degrees. And that gives you 39 degrees. Okay, and again, the true information that you were given, like, I mean, I guess you were kind of given 98 as well. You're given quite a bit. So I actually just want to figure out how tall the pole is. So to figure out the length of the pole, you're actually looking for A. So I needed C if I wanted to use the 22 feet that we were given, right? Because angle C, right? Angle C and side C have to go together. So angle C and side C, or sine of angle C, is going to be equal to side A over the sine of angle A. So to do that math, that would be 22 feet over sine of 39 degrees equal to little a, which is the we don't know, over sine of angle A, which is 43 degrees. Again, if we cross multiply, we'll do 22 times sine of 43, whatever that is, divided by sine of 39, and we will get that A is about 23.84 feet. And we are done. All right, guys, if you have any questions, please be sure to come see me for tutoring.